Okay, so now atom economy. Atom economy is also kind of similar calculation to percentage yield, but it is easier, okay, because you don't have to calculate the number of moles. You just have to know the MRs, okay, of each of the products of a reaction. But what is it? So we have a kind of word definition here, okay, so me trying to explain it in words is a measure of how intrinsically wasteful a reaction is. But the higher the atom economy, the less wasteful it is, okay? So it is a measure really of how much of the reactants you start off with end up in your products and not in the waste products. So for instance, we have an example here, but first let's have a look at the equation, how to calculate it. Okay, so it's really an easy calculation. You put the MR of your desired product at the top, and at the bottom the sum of all the MRs of all products, okay, and then times 100. So it's really simple. So this example here, we have 2-bromopropane, and it's a substitution reaction, it's a hydrolysis. So we get propan-2-ol and a waste product, which is HBr. So we're going to assume that this is our propan-2-ol is our desired product. So when you have a waste product, that is the problem then with a reaction that you're going to use for an industrial process. Okay, that if you have another product apart from your desired product, then the atom economy is not going to be 100% because some of your atoms that you started off with ended up in your waste products. That's why it's called atom economy. Okay, so in this example then I have put the MRs here, okay, so 60 and 80.9, and simply just your MR of your desired product at the top, the sum of the two products at the bottom times 100, and the atom economy is 42%. So that is quite poor, okay, it's quite a low atom economy. So if you wanted actually to produce this product, propan-2-ol, and get a better atom economy, you could actually use a different reaction. Okay, so for instance, if you put a chlorine here instead, then the MR of the waste product is going to be lower. That means it's going to be less waste. There's still going to be some waste, so you might want to find another reaction in which you can produce this product that has a better atom economy. It's not the only reaction that produces propan-2-ol. Okay, and the only way of improving the atom economy without changing the reaction completely would be if you can find a use for your waste product, in which case it stops being a waste product, it's going to be just another product. So if you find a way of then using that for something, then you're producing the two things you want, then you improve, in fact in that case the atom economy for your desired products would be 100%. So we have another example here. The second example on atom economy is this one here, okay, so in which we have propene reacting with water to produce propan-2-ol. So we are producing the same product as before, but actually here, as you can see, and if you remember from when we did addition reactions, there's only one product. Okay, when there's only one product, then the atom economy is 100%, because obviously you divide the MR of this by the MR of this, because there's only one product. That would be the same number, so it would be 1 times 100 is 100. Okay, so if you really want to have a very efficient process, then you could actually use an addition reaction. It would be, obviously you can't always do it, okay, but an addition reaction in terms of the atom economy is the most efficient type of reaction because it produces only one product and therefore it has 100% atom economy. Okay, now to compare a little bit atom economy with percentage yield. Okay, so percentage yield has to do a lot more with the process how much you manage to save from waste, like when you're doing your purification. Also, how much you manage to convert all your reactants into your products. Okay, so it has to do how the process is implemented. Whereas atom economy is once you chose what reaction you're going to use, then there's nothing you can do. Okay, so atom economy is something more intrinsic, if you like, and percentage yield is something to do with the process and all the stages and steps in order to carry it out in an efficient way. And that's the difference between the two. Okay, now in an industrial process, you need both of them to be high or as high as possible. And sometimes if I have to compromise one in favor of the other and so on, because there are all sorts of variables that you have to take into account.